building those fundamentals that you're going to use and apply on the range to make you the best shooter that you can be. All right, is everybody going to be at the same level, you think? No. Some people are going to, get it faster than others. All right, you're all going to get it by the time you're done. All right, I promise you. All right, I told you at the beginning, you're going to be amazed at what you're going to do with these rifles. Okay? And I meant that. And I also meant when I said that you had the best weapon system right now for an SDM in the Army inventory, I meant it. Because I've shot these, we've trained these. I've also trained other weapon systems doing SDM. Right? M16s, M110s, M107s. Anybody know what the 110 and the 107 is? Yep, they're sniper rifles. Right? I have trained those for SDMs that were using them as SDM rifles for Overwatch and IED defeat. In fact, the unit that I trained they're in theater right now. All right. 107's good weapon, 110's a good weapon. But for an all-around SDM gun, this is the best thing going. All right, guaranteed. All right, so this afternoon we're going to talk about range estimation, target engagement, and we're going to set up your optics. Go ahead, where am I? There we go. Let's go ahead and pass these back. All right, somebody go ahead and read that.
Majority of misses are due to incorrect range estimation. Correct by this, constant practice and application will ensure that you're proficient and will give you the best chance to achieve. One shot, one kill.
Okay. Why do you think most misses are due to range estimation? Okay, we're not shooting at the right range. Why would that be a problem? Go ahead. What do you?
You don't know how to compensate or effectively use your sights to hit your target.
Okay, we can't compensate and accurately adjust our sights. What does that cause? Causes a miss, but why does it cause a miss? Because of trajectory. Good. Bullet drop. All right. Is that a known constant? Yes, absolutely. There are things that will affect trajectory, right? But most of them have very, very minor effects. Right? Your trajectory is known. If you estimate your range properly and you adjust your sights correctly, you will hit with the first shot, right, as far as elevation goes. Right? If you do not, then you will probably miss with your first shot. Now, close in, 300, 400 yards, 500 yards. How critical do you think range estimation is? Not very. All right. You can be off on your estimation at 400 yards. If you guess or guesstimate it's 425 yards and it's actually 400, is that going to cause a complete miss? Probably not. All right. You were going to hit somewhere. Now, one of the things that you need to understand up front going into this is that there is a difference between an SDM and a sniper. All right. For an SDM, I'm shooting at what? E-type silhouette, basically, right? Okay, I'm aiming center mass. All right. What's your goal? To hit the target. And to cause it to do what? Not necessarily die. Stop what they're doing. All right. Your job as an SDM is to place accurate rifle fire on target and to stop bad people from doing bad things. Right? Do we necessarily want to kill them or necessarily need to kill them with the first shot? No. If we do, hey, bonus. Okay? But your job is to stop them from doing what they're doing. All right? So, if you're shooting competitively, you were trying to hit what? All right, the black, the center of the target, the X-ring. All right, however you want to term that. All right. Is it our goal to hit the center of the target, the X-ring, when we were shooting these guns as an SDM? Sure, that should be your goal. Is it always going to happen? No. But as long as you can effectively place that round on that target and get him to stop, mission accomplished. All right. All right, range estimation. Somebody go ahead and read that one.
Process of determining the distance between 2 points. In most situations, one of these points will be the observer's position. They may be the target or prominent feature. The ability to accurately determine range is a key skill needed by the shooter.
Okay. Range estimation, all we're doing, we got point A, point B. And we're figuring out the distance between the two of them. Now, there's a lot of ways that we can do that. All right, we're going to talk about all of them. Okay, the first one is map estimation. Okay, how do we do this? Has everybody done this before? Sure you have. Everybody gone through land nav, right? All right, so how do we do it?
Pick a prominent feature on the map that you can actually see and take a strip of paper and measure out how far away it is from your position.
Okay, then you're laying it down on that little grid on the bottom, right? And it's telling you range. Right? Does it work? Sure. How accurate is it? Kind of depends on you, right? Accurate enough for land nav. Is it generally going to be accurate enough for what we're doing here? Maybe, maybe not. All right. The answer to that is probably not. All right. One of the big things, what it said in that paragraph on range estimation, what's one of the critical factors? Practice, right? With all of these methods, the more you do it, the better you're going to get at it. Okay. The second one is a 100-meter unit of measure, or 100 yards. All right, how long is a football field? 100 yards, right? Can you visualize how long a football field is? Okay. All this is you are visualizing the distance between that target, you and that target, in football field increments. All right, so if I'm looking at a target and I think, well, I'm looking at that target, I'm saying, hell, he looks like about 4.5 football fields away. So he's about 450 yards, right? Now, what do you think some of the shortfalls of that one might be? Okay, if you never played football and you don't know how big a football field is, exactly. Right? If I'm not sure, how could I do it? How could I visualize or train myself to visualize how long a football field is? Go stand on a football field, or yeah, pace it off, right? Pace it off, look at it. Pace it off, look at it. Right? Again, it's repetition, repetition. Hey, appearance of objects. All this is I'm looking at my target, or I'm looking at an object, a prominent object near my target. All right? And I'm using it and how it looks, what I can see, to determine range. All right? So if I'm looking at a target that's 200 meters away, everything on them should be clear. I should see them clearly. And I'm not talking through your optic now. I'm talking with your eyes. I should be able to see everything on them clearly. Okay, at 300 meters, what starts to happen? Starts getting right. All your facial features, whatever, start getting a little bit blurry. You still should be able to see the outline. Everything else should be clear. But those features should start getting a little bit blurry. All right, 400 meters, 500 meters. As we increase in range, what starts happening? Exactly. What we can see becomes less and less distinct. Now, can this be an accurate way to judge distance? It can't, somewhat. It can. You're right. But what do you think this one requires? That'll help. Okay. If your eyesight's not perfect, that's okay, because it's what it appears like to you. If you know an object is 200 meters away, like you're on a rifle range, and you're looking at that E-type silhouette as 200 meters away, how that object looks clear to you, that if you go someplace else, like out in the field, and look at something and it looks about the same, it's about 200 meters away. Okay? How much practice do you think this one requires? A lot. Okay? It is just like shooting, except even more so. All right, shooting, one of the things about shooting is that shooting is a perishable skill, which means what? If you don't use it, you lose it. Okay, it's something that you need to keep your level high, you have to continuously practice. Do I always have to fire live rounds? No. I can do things like dry firing. All right, but I need to constantly keep practicing, even more so with range estimation. Now, an appearance of objects. Some of the things that can affect that is the nature of the target, nature of the terrain, and lighting conditions. All right, if a target has a regular outline, if you can see it clearly, the clearer you can see that object, the closer it's going to look to you. All right, versus something that's blurry and indistinct, like if maybe I'm looking at it through fog or something like that. All right, contrast with its background. What do you think that means?
How much it stands out.
Exactly, how much it stands out. All right, if you were wearing bright orange and you're standing up against a black wall, how much you think that's going to stand out? Pretty well. All right. If you're wearing stuff like what you're wearing, all right, and you're in an environment where you're blending in, how well are you going to stand out? Hopefully not very well, right? That's kind of the whole point. All right. Smooth terrain. If I'm looking at an object and I'm looking at something over a flat football field, all right, generally it's going to appear closer to me. All right, and that's because of the ground. All right, looking out over smooth terrain or even terrain, they're going to look closer. All right, next one is the depression. Why do you think something might look closer over depression? Because I can't see what's in between. All right, especially if I can look into that, if I can't look into that depression. All right, if I've got a long, even, smoothing, sloping surface that I can see, maybe not so much. All right, if there's a great big, let's say there's a great big crater in the earth, and from where I'm laying, I can't see across it. I can see there's a depression there, but I can't see that intervening surface. All right, that's going to make that object look closer because I don't have any reference point. Okay, kind of messes with my eyes a little bit. Okay, looking uphill. Why do you think looking uphill at a target might make it look closer? The slope of the hill, because I'm looking up, anything above me is going to look bigger, right? If it looks bigger, it's going to look what? Closer. All right, size of an object. If you see a vehicle and it starts getting bigger, which direction is it coming? Towards you, right? Right? Works the same way here. All right, in a straight open road, same thing with looking over a flat, smooth surface. All right, target will appear more distant if it has an irregular outline. Why would an object have an irregular outline?
More people, only one person.
Okay, more than one person. What could cause an object to have an irregular outline? Weather, clothing, okay. What else? If he's standing like maybe in the middle of brush or something like that. Yep, there you go. If it blends in with its background, okay. Camouflage tends to make things look farther away. Right. If it's only partially exposed, right. If all I can see maybe is part of somebody's shoulder or part of their body, it's going to look like it's farther away because I can't see what I'm thinking I'm going to see, basically. All right. If you're looking over contours, right, because of the slope of that contour, if you're looking at an area where it slopes up and down, right, what matters? The straight distance between me and that target, right? But what am I looking at when I'm looking at that intervening terrain? My eyes are following the slope of that terrain, and is that distance going to be farther away? Yeah, that distance is going to be farther away, where I'm actually should be looking at is straight to that target. But looking over that terrain can make things look farther. All right, so all that with appearance of objects, what do you think that means? Is this a reliable method of judging range?
Not precise.
Okay, not precise. Can it be precise? Can it be accurate? Yes. With a lot of practice, exactly. All right, we go back to that practice thing again, an application, right? All right. Okay, light conditions. Okay, same thing. If a target is clearly seen, it's in the sun, all right, or if the sun is behind you on that object, all right, it's lit, it becomes very clear, very distinct, all right, versus if the sun is behind the target, all right, if you're looking into the sun. Okay, if it's cloudy, limited visibility, it's going to make things look farther away. All right, goes right back to what we were talking about a couple minutes ago. All right, so what are the factors that affect appearance of objects? Okay, distance, visibility, contrast, okay. What else? Terrain, there you go. All right, nature of the target, nature of terrain, and lighting conditions. Okay, how can a target appear further away by the nature of the terrain? Okay. If you're saying if you're on the top of a hill looking downhill, okay, good. What else? Okay, depression. Okay, looking downhill, looking across a depression. Bracketing method. I kind of like to call this like the guesstimate. All right, which really it is. I'm looking at something and I'm estimating it. And I'm saying it is closer than this. It's at least this far away, but it's no farther away than this. Now, if I'm looking at that target and I'm looking at it saying, well, looks like it's at least 500 yards away, but it's no more than, I know it's no more than 7. Because I can look on my map and say, well, I know for a fact it's no more than 7, but I think it's at least 5. So what would my estimate be? 6. Okay, basically, I'm going to split the difference between those two estimates, my near and far one, all right, and that's what's going to be my range estimation. Okay, range cards. Who knows what a range card is? Okay, what's a range card?
An outline of the land that you measured and already pre-drew.
Exactly. All a range card is it's a picture of what's out in front of me. Now, what are some of the things we can have on a range card? Okay. Distance, direction, objects. What else? Terrain. There you go. Okay, distances. Right. So I know the distances to different objects. Right. Likely avenues of approach, road junctions. Right. Places where I think the enemy's going to come. Now, generally, are we going to be using, you guys could think you're going to be using range cards? Probably not. All right, range cards are generally in fixed defensive positions. If you're going to be in an area for a long period of time, say on an overwatch, do you think it might be a good idea to whip out a piece of paper and maybe do a sketch of what's out there and maybe try to do some range estimating or try to gather some range information? Sure. That would be a good idea if you have the time. Generally speaking, you're probably not going to. Now, laser rangefinders. Anybody used a laser rangefinder before? Okay, a few of you. All right. How does a laser rangefinder work? Okay, point and shoot. There you go. Okay. That's pretty much it. How a laser rangefinder works is when I look at a target and I hit the button. All right, what it's doing is it is sending a laser downrange. It is hitting that object, it's reflecting back to me. The time it takes for it to get to that object and back, then it calculates that time to determine distance. Now, how accurate are laser rangefinders? Generally, they are very accurate. Most of them will range to within plus or minus 1 meter or plus or minus a yard. All right? They are very, very accurate. Now, are they perfect? Nope. Why wouldn't they be perfect? Yeah, they break. Okay. Batteries. My batteries die. Well, now what have I got? I guess I can throw it as far as I can down range, estimate the range to that, and then use the football field method. All right. Basically, it becomes useless without the batteries. If it breaks, it becomes useless. There are some other limiting factors to laser rangefinders that a lot of people don't cover or don't understand. All right. The biggest one is it has to hit that target and reflect back. All right. One of the things, Sergeant Javasi and I, when we left here yesterday, we were driving out, he had his laser rangefinder, and there was a soldier walking across the field, and he tried to range him. Couldn't get a reading. Why do you think that would be? Oh, it'll work on a moving target. Nope, wasn't hitting the glass. Now all those things can affect that, all right? The steadier you are, the better a reading you're going to get. All right, so a lot of movement. The best way to use a laser rangefinder, especially for long distance, is on a tripod, small tripod. Because the steadier it is, the better the reading you're going to get. All right? But the biggest reason why he couldn't range that soldier was because of what they were wearing. All right, the uniforms that you guys have on, they're made to defeat what? AR and laser rangefinders. All right, the reason why they're treated to reduce your IR signature. The reason why they tend to defeat a laser rangefinder is because of the material they're made out of. All right, these things are real soft, right? They're soft. They've got a lot of the fabric that they're made out of. That laser has to hit something and reflect back to it. If it cannot reflect, you won't get an accurate reading. All right? The more reflective an object is, the better it is. So if you're trying to, let's say you use a laser rangefinder on somebody downrange and he's got one of these big old, whatever it is they wear, all right, can you get a good accurate range estimation or a good range reading? Maybe, maybe not, depending on how far away they are. Now, if there's a great big rock sitting there right next to them, what can I do? Range the rock. All right, the more reflective the target it is, the better the reading you're going to get, the more accurate reading you're going to get. All right, and the farther away you are, the more that becomes critical. All right, these have this particular one will go out to 1,000 meters, but it will not go out to 1,000. It will actually go beyond 1,000 meters on an extremely reflective target, extremely reflective surface, like a vehicle. A civilian vehicle. Got nice shiny paint jobs, stuff like that. Makes that laser reflect back very accurately. All right, something that has a very soft surface, doesn't reflect the laser real well, I maybe can only get 300 or 400 yards out of it. All right, so it depends. Okay, so they're not infallible. They are very good. They do work very well. All right, but they're not infallible. Okay, combination method. All this is saying is that the more estimates you can get of range, probably the better off you're going to be. All right, one of the best ways to learn how to estimate range is to go out, look at an object, estimate the range. I think that tree over there is 255 meters away. All right. Now I'm going to whip out my laser rangefinder, and I'm going to range it. And if it comes back and says 247, did I do a pretty good job? Yeah. Now if it says 371, do we have a problem there? Yeah, might. Okay, might need to have a little bit more practice. All right, but the more methods that I can use, the more confident I'm going to be in my range estimation. All right, now we come to the final one. Mill relation formula. Now, what I'm going to start throwing at you guys is a lot of stuff, okay? There's going to be some math involved. And part of what I'm teaching is what they teach to snipers. All right? This is the method that snipers are primarily taught to use. We're going to do it a little bit differently than what they're taught, and we're going to make it a little bit easier for you. All right? But mill relation formula is really the one that I like the best. Why do you think that is? It can be very accurate. It does require practice. It is most reliable. Why do you think that is?
That's math that never changes.
Well, okay, the math never changes. All right. Where is that mil relation, or where is that mil dot reticle in? In my optic, right? So as long as my optic is functional, I have my ability to range. Doesn't require batteries. Okay, as long as I can see my target and my reticle is functioning, then I can range the target. All right, so it's always there and it always works. If it doesn't work because my optic is damaged or there's a problem with my reticle, now what? It kind of becomes irrelevant, right? I'm going to be pulling it off and going to my iron sights anyway. All right, so it's always there. Now, mil relation formula, using your mil dot reticle, requires several things. One of them is practice. Okay, the second one is a steady position. Okay, the steadier the position that you have, the more accurate your range estimation is going to be. Now, we need to talk about some of the words we've thrown out here. Was minute of angle. Anybody know what a minute of angle is? Go ahead. What do you? Okay, that has a relationship to it. You're right. Okay, it covers 1 inch at 100 yards.
That's how much your round moves left, right, up, down every 100 yards.
Okay, that has we're getting a little bit we're getting closer to it.
The amount the round moves left, right, up, down at 100 yards, 1 inch, 200 yards, 2 inches, exponentially, and so forth.
Okay. Go ahead, Sergeant Anderson.
Exclude the bullet part of it, okay? If you think about, in a navigational sense, 1 degree, right, on a compass, 1 degree is 60 minutes. So if you draw a minute of angle at the South Pole, as you move towards the North Pole, it crosses the equator, all right? It actually encompasses 1 full degree, or 1/60th of 1 degree at the equator, and then makes itself back down to 0. So it is an angle that creates a measure of displacement that is 1 inch at 100 yards, 2 inches at 200 yards, so on and so forth, until it gets to the equator and then comes back to 0. Okay? So it's 1/60th of 1 degree. But because of that, that's how we measure shot group. That's how we bring it into that. Okay? And that's how we bring in bullet deflection to it. But the actual term of minute of angle actually comes from nautical navigation and has nothing to do with ballistics or marksmanship. But that's how we incorporate it.
All right. Does everybody understand that? All right. When you look at your compass, what's your compass broken down into? Degrees, right? 360 degrees on your compass. Every one of those degrees is broken down into smaller parts. All right, so every one of those 1 degrees is broken down into a smaller part. And there's 60 of them in there. That is a minute. All right, those minutes are broken down into smaller parts as well, and they're called seconds. All right, there's 60 of those in every minute. But the reason why we use minutes of angle is because our degrees are not precise enough for what we're doing. All right, so we're using a minute of angle. Somebody said a minute of angle is 1 inch at 100 yards, 2 inches at 200 yards. All right, yes, it is. But that minute of angle, all right, which is an angular measurement, remains the same. If people ask me what a minute of angle is, it's a minute of angle. It may express, all right, a certain amount at a certain distance, but a minute of angle doesn't change. All right? And that's what it's important for you guys to understand that with some of the things that we're going to be doing. All right? Yes, 1 inch at 100, and it continues to increase 1 inch. So at 1,000 yards, how much is a minute angle? 10 inches. Very good. All right, milliradians. There it is. All right, we talked about minute angle. Milliradians. What have you seen before that's been expressed in mils? Yeah, call for fire, okay. What's that coming off of? Your compass, right? Your compass is broken down into degrees, and it's broken down into mils. All right. How many mils are there in a complete circle on your compass? All right, 6,400. All right. The Army says there's 6,400 milliradians in a circle. Well, they're wrong. There are 6,280. All right. The reason we can prove that is because what is the formula for a circular equation if you're doing math? Okay. Anybody ever seen that before? All right. What's pi? 3.14, right? So 2 pi in a circle, 3.14. 2 times 3.14 is what? 6.28. So that tells me there are 6.28 radians in a circle. Now, when we say milli, what does that mean? Thousands, good. All right, millimeter is 1,000th of a meter. A milliradian is 1,000th of a radian. So to judge milliradians, we have to move our decimal point 3 places to the right. So now I have 6,280 milliradians in a circle. Right. You know why the Army uses 6,400? Exactly, it makes the math easier when you're doing a call for fire. Yeah, Sergeant Argaliers.
You know where it comes from? Come on, guys. The very first computers the United States or that the world had were in what? Do you know? Were the battleships Missouri? They were in the battleships Oklahoma. They were in the battleships Wisconsin. And in order to calculate that, the computers, the ballistic computers that were in those battleships were the size of about a quarter of a battleship. Did you realize that? That's how big these are mechanical ciphering machines, okay? They figured out it was easier to freaking calculate off of 6,400 than it was to calculate off of 6,280 to deliver naval gunfire. And that's why we do what we do.
Think about that. That computer, that supercomputer that was the quarter of the size of a battleship, your cell phone will probably do 1,000 more. Is probably 1,000 times more powerful. The computer chip inside of your cell phone is probably 1,000 times more powerful than that computer was. All right. Now, milliradians. Now we because we're going to talk about both, we need to understand which one is which. All right. A milliradian, 1 milliradian is equal to 3.5 minutes of angle. Now, I put the math up there, so I can either sit down and explain the math to you, or you can take my word for it. All right. All right. And it's easy. The calculation are, you know how many mils or how many minutes are in a circle. All right. 360 times 60. All right, how many mils are in a circle? 6,280. Divide those two numbers and you come up with 3.439. All right, so we're going to go with 3.5. All right, one other thing. I should have said this up front. If there's something you guys don't understand, stop me. Okay? I want to make sure you understand this. Because, again, like I told you before, you've been told do and don't how many times in your Army career? Yeah, how many times have you been told why? Not a lot, right? Maybe I'm kind of crazy that way, but I think that if soldiers understand the why or the why not, they're more inclined to do or do not, and more inclined to get it. All right, so 1 minute of angle at 100 yards is what? 1 inch, right? 1 mil at 100 yards is what? 3.5 inches, okay? At 300 yards, right? 1 minute is what? 3 inches, and 1 mil is what? Okay, 10.5 inches. The reason why we're doing this, the reason why I'm trying to make you guys understand the difference, is because the way your optics work. All right, your adjustments are in minutes, but your reticle is in mils. All right. Yeah, there are optics out there that your turrets are in mils now, and they're starting to become more and more prevalent because there are also reticles that are in minutes. Right? Because somebody figured out that, heck, if I look at my reticle has the same calculations that my turret does, it'll make things a little easier for me, won't it? All right, your Mark IV, the reticle inside of your Mark IV. All right, when you look at it, the space from every dot, all right, from dot to dot, the center of the dot to the center of the next dot is 1 mil. All right, which is how many minutes angle? 3.5. Very good. All right. From the center of my reticle to the center of every dot, right, adjacent to it, is 1 mil. Okay. Your dots themselves are 0.2 mils, and they're round. Some optics use an oblong type. All right, the Army uses round mil dots. The ones the Marine Corps has are oblong. Or have they gone to round now? Oh, they have gone to round. Okay. All right. And the space from the inside to inside edges of from dot to dot is 0.8. All right. So, here's the question. So from the outside to outside on my dots is how much? 1.2. Now, why is it important to know that? Why do you think that I put it? That's one of those pages that I printed off for you. Because the more reference points I have, or the more sizes I have to reference, the easier it's going to be to range. All right, so again, from center line to center line, or from center line to edge in this case, is 1 mil or 3.5 minutes. Okay, again, and I'm going to say this again, the key element when we're using a mil relation formula is a steady position. All right, I need to get that position as steady as I possibly can, because what I'm doing is taking my target and I'm bracketing it, right, in that reticle. Okay, I'm going to show you a few examples. Basically, it doesn't matter where you put it in that reticle, because you're measuring from a reference point on that reticle to another reference point. Okay. The formula to calculate is, first thing I have to know is the size of my target, either in yards or in meters. Right? If I put that in meters, my answer will come out in meters. If I put it in yards, my answer will come out in yards. All right, there's a reason why I'm saying yards here instead of meters. Why do you think that is? Anybody notice, you looked at your, go ahead. All right, that was going to be my question. So I know at least one guy looked at his scope turret. All right, it is in yards.
Also, a lot of the ranges we use throughout the military in the world are graduated in yards. You have 100-yard lines, 200-yard lines, 300-yard lines. There's very few ranges that have actual meter lines. And that's another reason.
Yep. And we're going to get it in very much in depth with this scope here in a little bit. All right, so I take the size of my object in yards or meters. All right, multiply that times 1,000 and divide it by my mil reading, whatever amount of mils that it covers, that target covers. Now I said the size of the target. Okay, one of the real advantages to the mil relation formula is that I can range anything as long as I know one thing, and what's that? The size of the target. Okay. You guys got snipers attached to your units? Some of them? All right. What do you think? What's one thing that they will probably always, every one of them has in their pocket? Maybe a calculator, maybe a dope book. But there's one thing I'll guarantee you they all have. Yeah, so maybe. Maybe not. Yeah, or somebody's. Think about it. I need to know the size of an object. Tape measure. Why do you think they'd have a tape measure in their pocket? Because they measure everything. Why do they measure everything?
So they know no matter what.
Because the more information they have, all right, the better they're going to be able to range. Okay? They'll measure the tires on a vehicle, all right, door openings, windows, because the more of that stuff that they know, the easier it's going to be and the more accurate their range estimations are. All right? Do you need to do that? No, because I'm going to make it easy for you here in just a minute, all right? We are not are we shooting doors and windows and wheels on vehicles and stuff like that? What are we shooting? People, right? All right, so the size of your target. All right, if your target is 60 inches tall, how much is that in yards? 1.7. Right. If it's 36 inches tall, how much is that in yards? 1, right? How big is a human being from the top of their head to about their waist to the groin area? 36 inches. Now, is everybody exactly 36 inches? No. All right. If you've got somebody who may be vertically challenged, all right, maybe 4'10", versus you've got somebody 6'8", all right, 7'2", are there going to be differences there? Yes. All right, but across the human spectrum, all right, average height, the average height of a person, and to within about 6-8 inches of variation on either side of that. The majority of that difference in height is in what? Their legs. Exactly. All right, this dimension does not vary all that much. All right, and that's why we can use it. So, all right, I range my target. Now, notice I didn't put it at a crosshair or any place else. I picked that as a reference point. Does it matter? Nope. Okay. What it matters is if you understand it or not. All right, if it matters is if it makes sense to you and it's a reference for you. No, I'm not going to stand here and tell you, well, you got to put the vertical crosshair on top of his head or at his waist or whatever. I don't care. I don't care what you use. As long as it makes sense to you and you can get an accurate reading off it. Now, in this case, the target is 2.4 mils high. All right, so we're going to go back through the formula again. Again, it's size of the target in yards times 1,000 divided by your mil reading. So, if we had a target that was 6 feet tall, and I can range, and I can say I can measure him completely from head to foot, how far away is he? And he's 2.5 mils high. How far away is he? All right, if he's 60 inches tall, how much is that 6 feet tall, how much is that in yards? 2, right? Times 1,000 is what? 2,000 divided by 2.5 is what? 800. All right, so he's 800 yards away. Now, even if he is 6 feet tall, are we going to be able to range somebody from the top of their head to the bottom of their feet? Probably not. I'm going to say, I don't like the words always and never, but I'll go out on a limb there. All right, probably you're not going to see somebody from the top of their head to the bottom of their feet. All right, but waist to top of the head is usually a pretty good measurement. All right, especially if somebody's moving out there around there downrange. All right, so to make it easy, All right, 36 inches is how many yards? 1 times 1,000 is what? 1,000. So does that number ever change? No. All right. Now I take that 1,000, divide it by the number of mils that it covers in my reticle, and I come out with the answer. All right. So instead of doing all that math and trying to calculate it and convert it to yards or meters or whatever, as long as you range that part of them, 1,000 divided by your number of mils, and it's going to come up with the answer. Okay, another method to do this is bracketing. Bracketing is to place a target between the mil dots, kind of like doing your mil relation formula, right? The difference is you're using a predetermined relationship. Now, to do this makes it very quick and to give you an accurate reading. The downside to that, and what do you think the downside of that might be? Anybody? Okay. How might I do that? With a dope book. All right. One of the things that I'm going to give you guys when you go to the range is I'm going to give you the bracketing relationships. All right, you are going to get that, and it's going to be laminated, so you can take it to the range with you, and you can take them down range with you. All right. So if I look at that card, and he's covering 2 mils, how far away is he? Now, these handouts that you guys got, keep these. As we're going through this class, write anything you want to on them. These are yours. That chart is on there, and all the rest of the charts that I'm going to give you are on there. All right, so if you need to, you can make a copy of it and reduce it if something happens to yours. All right, I'm going to give you guys, you'll all have one before you go to the range, and I'm going to give you all the extra ones I have, so you can take them with you.
You had a wonderful question, and
Go
I'd
ahead.
like you to address it with the entire class.
Go ahead. What do you got?
The question was, when you play with the magnification of the scope, will that change the mil relation in what you see?
Yes, it will. And we're going to get to that in the next class, but that's a good question. Since you brought it up now, we're going to address it now. The way these optics work, right, I'm going to get a little more in depth why in the next class, but the way these optics work, your mil relation in your scope, all right, or in your optic, your reticle, will only work on 1 power. Right? And depending on which optic it is what power it is. All right, so you have to know if you go to use a different optic on a different rifle, it may be different. On this one, it is set at 10 power. All right, so it must be turned all the way up, okay, for your 1 mil to read 1 mil. All right, if you reduce your magnification, you're not going to. It doesn't work quite as well. All right, it's not going to work at all actually. All right, so it has to be set on 10 power. Which, if I'm ranging something, I want to see it as well as I can, so I'm going to turn the power up all the way anyway. So it kind of works out. All right, there are some optics where it doesn't matter, and again, I'm going to get into that in the next class. All right, so we talked about the 8 range estimation techniques. Right, talked about appearance of objects, laser rangefinders, mil relation formula. Again, laser rangefinders, they're a great tool as long as you realize that they do have limitations. All right, there are people out there that will tell you that they're the greatest thing in the world, they're infallible. Yes, they are a great thing, but they are not infallible. Okay? And a mil relation formula. Mil relation formula, there's a reason why they still, with all the laser rangefinders and the Storm and all the other stuff we have out there, there's a reason why at the sniper school they still teach mil relation formula. And they spend 5 days covering what we just covered. Because it don't take batteries, exactly. And it always works. Like I said, if it doesn't work, you're pulling this thing off and using your iron sights anyway. All right, so you always have it and it's always there. And if you're using your mil relation formula, when you achieve what's called a firing solution, all right, and make your adjustment however you have to, either with your scope or with your hold-offs on your mil dots, you're behind the scope. You're ready to take a shot. With a laser rangefinder, I got to do this, and then I got to do this, and then I got to do this. If I'm looking through it and I range it, and I go, oh, he's 2.5 mils. Ha ha. Bang. Or hold off. Bang. Right, so it's a very fast way to range and engage a target. All right, so what are 4 of the range estimation techniques? Okay, bracketing. Appearance of objects. There we go. Okay, mill relation formula. Laser rangefinder. Okay. All right, which method is the most accurate? Laser rangefinder. I don't care how good you get with a mill relation formula, you will not be you will not read within plus or minus 1 yard. Okay. Which one requires a steady position? Yeah, pretty much all of them. I mean, mainly the mill relation formula, but yeah, doesn't hurt to have it with all of them. It's hard to read. I guess if you're running from point to point, it's kind of hard to judge distance.